In this video, we are going to use block diagram reduction method to find the transfer function of this diagram. That is the ratio of our output C of S and our input R of S. We are going to use this table as a guide because it contains manipulation formulas, and we are also going to use this formula, which is the formula for resolving a feedback loop. So from our loop 1, you can see G1 and G2 without this summing point, they are in cascade. Also G3 and G4 without this takeoff point, they are in cascade. So in order to have them in cascade, we need to move this summing point ahead of this block. So as you can see, if we look at number 3, we have our formula for moving a takeoff point behind a block. So if you want to move it behind a block, you have to multiply it by the inverse of that block. So all we need to do is, if you want to move it, I need to clean up this, I need to clean up this. So in order to move this behind block G4, I need to multiply it by 1 over G4. So, and then I have my takeoff point here. So if you look at row 6 of the table, if I want to move a summing point ahead of a block, I need to multiply the path by the reciprocal of that block. So it means I need to have 1 over G1 in my path. So 1 over G1. So now, after doing that, I can remove this summing point and I can adjust my diagram. So it means I will have my new summing point here. So I have my negative here and I have my positive here. Then I will have my G1. So now, as you can see, I have these two blocks in cascade. So if you look at row 1, I just need to multiply them, the ones in 1 and the ones in 2. So all I need to do is to clean up this, and I will have my new block. So this one will just be G1, G2. And for this one, if I clean them up, I will have my G3 and G4. So you can see now I have my feedback loop completely here. So I can combine these two summers, but I have to appropriately consider the sign. So as you can see, I have positive, negative. Whatever is coming out as a signal, since this one is positive, I just have to subtract the signal from this part. So all I need to do is I can remove this and then take this part to here, but I have to consider the sign, which is negative sign. So all I need to do is to remove this and then complete my part. So I have two feedback loops, 1 and 2, and I can then use this formula. So for the first one, so I can just using this formula, this feedback loop 1 will just be G1, G2 all over 1 plus G1, G2, H1. So for my circle loop, using the same formula, which is this one, it will reduce into G3, G4 all over 1 plus G3, G4, H2. So also, if you look clearly, these three blocks, they are in cascade. So I can use the formula in row 1 from my table, they will just be H3 all over G1 times G4. So all I need to do is to clean up this part, and it will be substituted by a single block, which will give me H3 all over G1 G4. So I'm done with this formula. So I need to substitute 1 and 2 also. So I need to clean off this part. So I also need to do the same thing for this one. So this one will also be substituted by this solution. So I have these two blocks here, and as you can see, they are also in cascade. So since they are in cascade, I'm done with these formulas. So since they are in cascade, I will have this row as my guide. So I need to use this formula. So the combination of this block will just be G1, G2, G3, G4 all over 1 plus G1, G2, H1 into 1 plus G3, G4 and H2. So I can remove these two blocks. So I'm done with this formula now. So if you look clearly at the current state of the block diagram, it is also a feedback loop. So it is similar to this loop. So in this case, the one down one is my forward part, which is my P1, and the one upward is my feedback part, which is my P2. So using that formula and resolving, I will have, so the one in purple is my P1 and the one in red is my P2. So if you look at the denominator, I have G1 and G4 here, and I also have G1 and G4. So this G1 and G4 will cancel each other. And then finally, I will have a complete block that represents my transfer function. So I have my C of S here. So if you look clearly, I have my numerator here, the numerator part here. I will have my G1, G2, G3, and G4. So I will have my denominator. So this part here, if it comes down, it will multiply 1, and I will have, so apart from multiplying 1, it will also multiply this ratio. But if you look at the denominator here, it is the same thing as the one here. So they will cancel each other, and I will be left with G2, G3 times H3. So I will have plus G2, G3, and H3. So this is the transfer function that relates my output C to my input R. So if you want a comprehensive discussion on Root-Howard stability criterion, watch the video on the screen. Please like and subscribe to the channel. Thank you for watching.